This video is for topic 14, video E. It is given that dinitrogen pentoxide can be made by reacting nitrogen gas with oxygen gas. Written, the chemical equation on the left is what's given, but this is not a balanced equation. The chemical equation on the right is balanced with 4 nitrogens and 10 oxygens for both product and reactants. For reference, the number of moles for each molecule is provided on top of the balanced equation. The amount of grams for each reactant is also written underneath the balanced equation. The next step is identifying the limiting reagent. We take 35 grams of diatomic nitrogen and divide it by its molar mass. The result is 1.25 moles of nitrogen. We then multiply the molar value by the ratio using the moles of the balanced equation. With 35 grams of nitrogen, 1.25 moles of dinitrogen pentoxide can be produced. We do the same for oxygen, which is also diatomic. With 80 grams of oxygen, only 1 mole of dinitrogen pentoxide can be produced. Oxygen is the limiting reagent. The last step is converting the moles of the limiting reagent value to grams. 1 mole is multiplied by the molar mass of dinitrogen pentoxide. The maximum number of dinitrogen pentoxide is 108 grams. Question B asks for actual yield. We rearrange the percent yield formula to solve for actual yield. What's given to us? Theoretical yield equals 108 grams of dinitrogen pentoxide. This was our solution from question A. We are also given the percent yield, which is 55%. After applying the given values to our rearranged equation, we find the actual yield to be 59.4 grams. Question C asks for you to work backwards. The first step is to compute the theoretical yield. To solve for theoretical yield, we also rearrange the percent yield formula so that 100 is divided by the percent yield value. The product of 100 divided by percent yield is then multiplied by the actual yield. The question gives us an actual yield of 130 grams. We solved theoretical yield to be 236 grams. The next step is to divide the theoretical yield by the molar mass of the product to give you the amount of moles that could be produced from the limiting reagent, which is actually the amount of moles that could be produced from the reactants. We are able to calculate 2.17 moles from dividing 236 grams by the molar mass of 108.8 grams per mole. The third step is to find the amount of moles that is present for each reactant. Using the balanced equation for a ratio, we multiply 2.17 moles by the ratio of 2/2. We find the number of nitrogen that initially reacts to be 2.17 moles. By multiplying 2.17 moles by the ratio 5/2, we find that we initially need 5.45 moles of oxygen to react. The fourth step is to compute the moles of each reactant to grams by multiplying the value of moles by the molar mass. Nitrogen's molar mass is 28 grams per mole because nitrogen is a diatomic element. 2.17 moles of nitrogen times 28 grams per mole equals 60.8 grams of nitrogen that could be used for the reaction. Oxygen is also diatomic, so we use 32 grams per mole of oxygen. 5.45 moles of oxygen times 32 grams per mole equals 174 grams of oxygen that could be used for the reaction.